Hey savvy people, it's SavvyNik here, and today we'll be going through another review of C++. This is intended for beginners. If you're just stopping in to watch this today, thank you so much for stopping by and watching the review. The very first program I want to create here is one that generates the Fibonacci sequence here in C++. We've, up until this point, I think we've learned enough in order to actually create the Fibonacci sequence now. So this will mainly take in and use a for loop and just keep track of a few variables that we're going to have in our program. Nothing too crazy, but it's a nice, easy little program to create, and it is going to use some of those concepts that we've learned in the previous, I don't know, 3 or 4 episodes. There hasn't been a review in a little bit, but been too busy with some of the other videos. The very first thing I'll do here is let's ask the user. So cout, I'm just asking for a number here. Please enter what sequence number you would like to go to. And this is really just to ask the user for a number. And we'll put that number into, let's call it num, so sequence number. This will allow us to take in a number, and that number will represent what sequence in the Fibonacci sequence we would like to get to. Hi there, Rumit. Nice to see you. Thanks for stopping by. Slendex, hey, how are you? Good to see you. Thank you also for stopping in. All right, so in order to use seq_num, I'm going to have to define it, and I'm defining it as just an integer up here. I won't set it equal to anything because I am defining it or asking the user to define it as soon as they run the program. So in order to make the Fibonacci sequence work here, let's see if I can't bring up Fibonacci sequence just to kind of get a good feel for what numbers we need. All right, let me bring this window in real quick. All right, and so what we can see here, we have some number n, and that number just iterates up by 1 in the sequence. And for every number in that sequence, we're adding in the last number and we're getting the result. So here's the actual Fibonacci sequence. We start with 0, then we have 1. 1 plus 0 is still 1. Then the next time through, 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 2 is 5, and so on and so forth, infinitely, really, until, well, whatever sequence number. So we're going to cap it to whatever the user wants in this program, but the user will get to choose what Fibonacci number to go to. All right. Hey, Sarah, welcome to the stream. Thank you for stopping by today. Yes, this is a live stream. This is not a premiere. Ramit, Matsu, welcome to the stream. Thanks for stopping in to say hi. All right, so we learned about for loops, I want to say like maybe 4 episodes ago. Again, we haven't had one of these in a while, so let's use a for loop here because we're going to need one since, well, as we saw in that previous website example I just brought up, we need to actually use an index and increment that index in order to keep track of our numbers and keep going down the line. So a perfect thing for that is a for loop. So in this for loop, I'm going to initialize a value, and I'm going to say I'm going to set it equal to 1 because that's where I want to start out from. I'm going to say I less than a sequence num. So I already defined the sequence num. That's what the user is going to give me. And I just want to keep incrementing I every single time. And that's my basic for loop here. Hey, Savvy people, it's Savvy Satish here. Welcome, Savvy Satish. Nice to have you here. All right, so in the for loop, I guess we can just make sure that things compile real quick. I haven't really tried anything out. Let's see. Where did I store this stuff? Maybe in my documents? Yeah, CPP. All right, do I still have this in here? Fib.cpp. Perfect. Okay. So in order to compile, I need G++. The file I'm trying to compile is fib.cpp. And I'm going to output that out to fib. Looks like everything compiled fine. And if I run fib, we're asked, please enter a sequence number that you would like to go to. How about 10? And then we just exit out because we go through this for loop basically, oh, let's see, maybe 9 times, and we exit out. So far so good. We got something stubbed out for our Fibonacci sequence here. Satish, I dare you to switch to the light theme. Yeah, that's not going to happen. We're all going to get blinded. All right, Rummet, see you later. Have a good one. All right, so now that we got our for loop, we need to think about how we're going to get that Fibonacci sequence going. So let me actually bring that website back up so we can kind of follow along with the website and know what we're actually trying to create. So according to this, let me see if I can make this smaller. According to this, we need to do first 0, 1, and then another 1. So at least for the first 2 iterations here, we can create a 1. So let's take care of that first. And we'll be using a continue for this one. So I'm going to do if I double equal to 1. So in the first iteration of the program, we're going to do something here. And then I'm going to use 2 pipes to represent an OR. So this means either this first case or if the second case is true. So I double equal to 2. I want to do something in here. Otherwise, I'm going to do a few things down here. So let's think about this for a moment. I'm actually going to create another, let's see, variable up here. I'm going to call it start. I'm going to set this one equal to 0, just so it's initialized as something, since I'm not going to be initializing it. And in here, I'm thinking, why don't we print out start and increment it? So I can just do ++ and do an end line to make things look clean. So that just creates a new line. And then I'm going to use a special statement here. This is a statement that we just learned about. We learned about the break, the continue, and the go to in the last video that I released on C++ for beginners. And if you haven't checked out that playlist yet, make sure to do so. It's on the channel. You can check it under the channel, under playlists. I have a whole C++ series for beginners if you want to learn about C++, and of course then you can follow along with these reviews. Also, if you're new and just stopping in, make sure to go ahead and smash that like button for me. It really does help me out. All right, so continuing on. So this will take care of my first 2 numbers, right? So the first time through their iteration is going to fall in here, increment start by 1, and let's just print out, well, actually it is printed out. And then after it's printed out, it's incremented by 1. So that takes care of, I guess, our first 2 cases. But what I'm missing is a continue, so we don't actually execute any other code in the program. Instead, we just continue on to the next iteration of this for loop. That's why this is important, and this continues going to work on the loop itself. All right, we just learned about that one, and I figured why not use it? Here's a good example. Next, we're going to have to think about how we're controlling our variables here in the Fibonacci sequence in order to keep track of a few things, because we technically need to know, let's see, did I erase it again? No, I didn't. Here we are. So we need to keep track of a few numbers. We actually have to keep track of the previous number and keep track of some kind of a sum total. So that's what we're going to be working on next here. I think it's fairly simple. So if we do something like, I'm going to call it fib to keep track of the Fibonacci number at the current moment in the loop. And then I'm going to define two temporary variables, temp1 and temp2. And these two I'm going to have to play with a bit in order to make sure that I'm keeping track of the right numbers, because again, we have to keep track of basically the last two previous numbers. So you can imagine if you're in the fifth sequence here, you'd have 5 plus 3, which is, or sorry, 3 plus 2, which is equal to 5, and so on and so forth. Every single time, you know, we're adding the last two previous numbers in order to equal the current sequence number. So that's kind of what this will do here. So our Fibonacci number is equal to some temporary number from a previous point and some other temporary number from a previous point. And we can apply this throughout the Fibonacci sequence. All right, so if that's the case, we need to also keep track of these temporary numbers. So temp1 is going to be equal to temp2 after we've used it. So I'm basically just moving a number that I already had and replacing it with temp1 so I can keep track of it for my next iteration. And then temp2 is going to be equal to fib. So fib is this number that we just got done calculating. So in order to keep building up, right, so I need to keep track of the number I'm currently at, so I create temp2 with the number I'm currently at. And then I have temp1 before I change up temp2, I gotta save that number that I had, and then the next time through the loop, we are basically adding fib and temp1, and that's the new fib. All right, hopefully that's making sense here. Hi there, Crazy. Welcome to the stream. Satish says, I would really appreciate a series on GitHub or Git. So source control. I do have a video actually on source control with Git in the C++ simple list series that I have. You might want to check that one out. Maybe it would help you. All right. I think it's like episode number 8 or 10. I'm not 100% sure off the top of my head. So continuing on. I think we're getting very close here actually to having something working, but we haven't really defined any of these numbers so far. So we need to create these variables up top. They're all integers, so I'm just going to put a comma up top, and I'll set temp1, we'll set that to 0. Temp2, I'll set that to 1. And let's see, am I missing anything else? Fib, I'm missing fib. Fib will be the last one we define. I'll set that equal to 0. So now we have fib defined, temp2, temp1, start, and sequence number. Everything seems to be checking out so far. The only other thing I need to do here at the bottom is I got to print out cout fib and do end line. So fib represents the current number in the Fibonacci sequence. So let's run through this real quick. So from the beginning, we define a bunch of integers here. Some are initialized, some aren't because they will be reinitialized right away. So we ask the user, hey, please enter a sequence number you would like to go up to. So they get to specify this number here up top, and then we specify, or we generate the Fibonacci number up until that sequence number. So that's all that does. And then we do for int, we start at 1. And we check from 1 to the number that they supplied. We're going to just keep incrementing this for loop so we can keep track of our numbers up until the number that they specified for us. So for the first two cases, we need to print out a 0 and a 1, and then we start using our for loop really at that point in order to generate these numbers. So that's why we have this case here. So if we're equal to 1 or 2, the first portion of the for loop, so the first time it goes through the for loop, second time it goes through the for loop, we're going to just use a variable called start. it starts at 0, so we'll print out 0. Then it's going to increment by 1. Then the next time through the loop, since we did a continue, it's going to go through the iteration to the next iteration of the for loop. And it's going to print out a 1 at that point. After that's done, this if statement is not true anymore, and then this bottom portion starts taking precedence. So in this, what we're doing is we're taking temp1 plus temp2. So temp1 at the beginning is 0, temp2 is 1. So 0 plus 1 is 1. And then temp1 is going to take hold of temp2. So since temp1 was 0 and temp2 was 1, temp1 becomes 1. So we got 1. Temp2 is going to become fib, so that's another 1. Now, next time through the loop, of course, we print that out. So what do we come up with? Came up with 1, so we print out 1. Then next time through the loop, we have a 1 and a 1. And that will represent our 2 at that point. And then we store the last two numbers, so the 2 and the 1. And then we just keep looping through here all the way until we get to the sequence number specified by the user. So I think that's really it here. I think we already have our Fibonacci sequence program created. So that was fairly quick. Of course, we couldn't have done this unless we've learned all the previous stuff. So the continue is important. Of course, the for loop is important. And we've learned all of this throughout the series for beginners. And if you are new and stopping by, make sure to subscribe below, hit the notification bell for more videos, as well as streams. I try to do one of these a week, as well as, I post multiple videos on beginner C++ programming content. So also make sure to take a moment and hit that like button for me. It really does help me out. I will now try compiling this. So I'm going to do Control J here. Looks like we compiled, no problem. Awesome. I'm going to run the program, clear things out to make things look a little better. I'm going to run fib. So I'm asking, what sequence number I'd like to go to. So I don't know, let's try 10. So if I type in 10, let's see, what am I getting? So I got a 0, a 1, a 1, a 2, a 3, a 5, an 8, a 13, a 21. All right. So we did actually generate the numbers. So that's really it for the Fibonacci sequence. That was quite quick, actually. So you can also place in, let's say, I don't know, if you wanted to do 100 numbers. Oh, looks like we got some kind of an overflow here. And that's because we're using integers. We're gonna so actually, if you wanted to be able to go quite up in the Fibonacci sequence, eventually the numbers start spiraling out of control here, and they get much bigger than what an integer type can hold. Therefore, it starts overflowing, and when you see it overflowing, you'll see this goofiness happening right here. All right, in order to fix that, we just have to use something like let's say a float in order to store the numbers, and that would help. Or if you wanted to even store more numbers, perhaps, let's say you could use a double even. But that's really it for the Fibonacci sequence program. I'll let you mess around with that one, improve it, of course. Like I just said there, you can do floats instead, or even try out, I don't know, doubles perhaps, and just see how that results into something else. The next thing I want to do is I want to write a very basic program in order to display that ASCII character set that we talked about before in one of the previous reviews. I kind of made mention that the characters are represented technically by integers, and those integers are looked up by like an ASCII character set. So we'll get that ASCII table out and kind of look at it one more time. That way we understand what we're looking at here, or what we're looking for. So give me one moment here as I bring this up. right. So here we have the various different symbols that a decimal number represents. So a 0 represents a null symbol, so on and so forth. We won't really talk about these special ones. But here, when we get into the actual printable characters, then we can actually start to see them representing symbols. So we have some like the exclamation point, the pound sign, so on and so forth. Then we have numbers. So a decimal 49 actually represents a 1 here as a character, so on and so forth. Capital letters, lowercase letters, and much more. So basically, we're going through the standard 255 character sets is what we'll display. So what we're looking for is, does it actually match up to what you can see, on the ASCII table? Does that actually all add up? So I will create a new program, so a new file, and actually I'll just copy this over. Come on, copy, paste. All right, and then I'll get rid of all this in between. That way we can use it. All right, save that. And we'll save it as ASCII. Satish asks, can an infinite while loop destroy my computer? No, it can't destroy your computer. The reason being is, worst case, you'd use up all your memory. Let's say if you had a memory leak, and it would probably just either a computer would catch that memory leak and it would shut the process off, or you might get the blue screen of death because you got too much memory usage in Windows, or your computer might start freezing. But to really destroy your computer, no, I don't see a way of doing that. And plus, you have to basically create an intentional or non-intentional memory leak, which isn't going to be done with something like this. It's just going to keep going. So Raikesh asks, what distro am I using? I'm using Pop! OS right now. Pop! OS is actually one of my favorite Linux distributions, and I have been using it quite a bit recently anyway. Let's get started by creating a character. This character is going to be called symbol. So we're displaying symbols, and what I'm doing here is creating the character as a hexadecimal formatted character. So I'm defining the character as a hexadecimal, and I'm just saying OXOO. So this actually here, if we highlight this, is saying it's casting it as an integer 0. This is really just to be able to read things a little easier, because you can't actually print out all the characters in the ASCII table. Reason being is some characters are non-printable. So let's say like the null and some of those special symbols that we have, or right here. So we have an SOH that can't really be represented as a character. Instead, it just means something to the computer, and what it means is here on the right-hand side. Therefore, we can't actually display them. So that's one of the checks we're going to have to make. We're going to have to make sure to see if a symbol is actually printable. All right, let's continue on here. So we've learned about while loops in the past, and a while loop is perfect in this case here. So a while, some condition in here is true, we will keep executing everything inside of here. So here's where we use our while. And the condition in here, I'm actually using, or going to use, a, let's see, we're going to check if our symbol is not equal to a character, and that character is 0xff. And let's see if it shows us here. Yes. So all the 0ff represents is 255 as a hexadecimal. So don't confuse yourself here. That's all that this represents, 255. So we're basically going from 0 to 255 here in our for loop. And let's see. That should be enough. So all I'm checking is to make sure that we're not at the end of the character table, which is at 255 255th point. So that's all we're doing there. And now I'm checking in here if something is true. Let's see. Else, I'm going to do something else. And I'd like to also, using this while loop, of course, the reason I want to use it is as I'm going through all the symbols, and they're not at the very end, right? Not at the last character. All I want to do is keep incrementing or indexing that symbol, that character, right? So this is defined as a character. So the first time through, of course, is 0. Then the second time through, it's 1, 2, 3, 4, 5, and so on and so forth. And what we're going to be displaying is the actual character that that decimal represents. So we should hopefully get that ASCII table out from this, or something very similar to it. Satish. Because I had a nightmare where I didn't end the while loop and my laptop exploded. Now I think you'd be fine. Swollen Burke, welcome to the stream. Thanks for stopping by today. All right, so here I need to check something in this if statement. And like I was saying before, some of those characters are now printable. So there's actually a special function called isPrint. And isPrint checks if a character is printable to the console. So I'm going to take advantage of that special function here, and I'm passing symbol into it, and as long as it is printable, this will return true. And if my statement is true, or if my if statement here is true, we're going to print out that symbol. There we go. All I'm doing here is just adding a character, and that's just the space to make things look a little better. All right, so otherwise, it's not printable, meaning it can't be printed to the screen or the console. So we can actually represent it some other way. We can still print something out, just not the same way we would do it above. I'm going to use the hexadecimal format of that symbol, so it tells us what it is in hex. And I can do that by, first I'm just putting this in front to kind of make it look similar to everything else that I have in my program. So the 0x right up front. And then the next thing I'm doing is there's this special hex, which you can see here is part of, let's see, iOS base. And it just converts a something given here on the right-hand side to a hexadecimal formatted number. In here, I'm going to do a mask. So let's see, 0x FF, and I'm going to mask that with my symbol. And I think that's, let's see, let me think about this. Yes, I can do that, and then I can do just another little space here at the end. That way things look a little better. Gives spaces between all the characters that we're going to print out. Now the one thing is, this will not work the way it is currently, because we are not this is currently a character, and in order to mask these two, we need it to become an integer. So if I did int something like this, that should work. So what this does is this just transforms this character into an integer value, and then what we're doing is we're masking or anding these two together over the top of each other, and then displaying it as a hexadecimal value, and we're putting this prefix here in OX. So hopefully you understand that. One other thing I need to do is, I think this is only going to run us out to the, I think we need one more element printed out here at the very end. So I'm going to do this. So I think this will get us all the way to like 254, and then it'll actually exit out, right? So yeah, it'll go all the way to 254, but whenever we actually finally reach 0xFF or 255, it's not going to run this code. Therefore, I'm just going to print out the very last symbol. Let's see. Should be something like that. Let's see if we can run this. So Control J, I'm going to clear things out here. This time it's called, let's see, G++, we'll do ASCII.cpp. We'll output that to ASCII. All right, and let's see if we can run ASCII, see what we get. All right, so we just got a whole bunch of hexadecimal and, well, maybe I should put an end line here. Maybe that makes it look a little better. But a whole bunch of hexadecimal and printable characters. So we'll actually check this up against the ASCII table and see if it comes out all right. Instead of this, let me put an end line here just to start a new line. And then I will recompile my program, rerun it. And now I have my ASCII chart here. All right. So let's check if we did all right. Let's see. So we said 0, right? 0 is a non-printable character called null. So that's right. So we're going through all here. So we're looking at this hexadecimal column, right? Because we printed it out as hex. So we're paying attention to this third column. Let me move this up a little bit. All right. So all the way to, let's see, 1F, and then I think at 1F, yeah, after 1F we go to 20, and 20 should be our first printable character. So 1F is right here, and it's not printable, so it displayed as this hexadecimal formatted, in hexadecimal format of a character. And then we have this space here. You can't really see it because it's space, of course. Then we have an exclamation point, quote, hashtag, $, so on, so forth. Is that starting to kind of match up what we're seeing here? Space, right? Yep. Exclamation point, quote, and yep. Hashtag, $, so on and so forth. Looks like things are adding up there. Very good. Very good. And we're going all the way. Here's our numbers, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We have a colon, a semicolon. So far, so good. We get all the way down to this tilde here. And then again, we start seeing non-printable characters. And the hexadecimal for that is 7F. So after the tilde, 0x7f comes to play. So awesome. And the rest of these, depending on your system, might actually be printable, might not, but according, at least in mine here, they are not printable symbols. Therefore, they show up as these hexadecimal formatted numbers here. So that goes all the way down to FF, and let's see if we found FF. We sure did. All right, so we just printed out at least all the printable characters of the ASCII table here in our program. And it was fairly quick and simple, not much to it. We can go through the program once more here. So again, we started our character symbol at 0x00, just because I wanted to represent it as a 0 in hexadecimal, because most of my programs using hexadecimal here to print out the characters. And then you could have just as easily used integers here, but that's fine. And then we did a while loop, and we checked if the symbol was equal to the very last character in the set. So 0xff is our last character in the ASCII table. And then we check if we can print out the character that we're currently on. Let's go ahead and print it out. Otherwise, let's print out a hexadecimal representation of that character. And then finally here, this is what increments our character every single time by 1. This last little line here is really just to cover the very last character in our table. So since we cut it off here, you could have also just fixed this, but just not to confuse things, I went ahead and printed it out at the end. Then we return 0 because everything turned out successful. And that's really it. So what's the difference between types of characters, char or wchar-t? So wchar-t just stands for a wide character. So it's a wide character can contain more characters than a normal character data type. That's all. Just like Victor says. All right. So unless anyone has any questions, that's about it. We did 2 programs already, the Fibonacci sequence, and we printed out the ASCII table here using such things as continue, while loops, for loops, characters were used in this one. I don't know that we've done an example with characters, but this is a nice one to kind of get a grasp around how they work and how they're represented. If you're new and you're stopping by, make sure to go ahead and smash that like button for me to get other viewers in. Get in on the C++ tutorial for beginners series that I've been creating on my channel. We're about on the 15th or 16th episode now. It guides you through programming in C++ as a complete beginner, learning the concepts of C++, and then of course we have these reviews occasionally where we do it live, and we get to kind of create a program together, simple programs. Also, of course, make sure to subscribe below, hit the notification bell, and if you hit that notification bell, you'll get notified when these streams come in. As far as the font goes, Rakesh, I'm not exactly sure what the font is. It's standard here, whatever is being used inside of whatever the standard is here for Linux. I don't know. But I think that's about it. If you have any questions, comments, or suggestions, please make sure to post them in the comments section below. Also, make sure to subscribe for future videos and make sure to like the video. Catch me in a great community on Discord, and I'll catch you in another video. Thanks for watching.